I'm a technical director here at Tesdo Lab, and with me here this evening, joining is Nikolais Varlamos. He is audio and video testing project manager, R&D lead, engineering manager, a lot of things in one. So I'll mute myself so he can also say hi.
Yeah, hi everyone. Also pleased to meet you here, and I really hope you will get at least some valuable information from this webinar. Yeah, so Dennis will start, and I will be in the middle, and yeah, we will juggle the webinar between two of us. Also, as he mentioned, yeah, I also would like to highlight that if you have any questions, you are welcome to write them in the chat, and during the webinar, I also probably will be able to answer some of them in chat.
Yeah, one more thing. We are recording the session. This is just that we can share this session with you after, or share to those who couldn't be here with us. And yeah, we're already 3 minutes over time. We're still looking at people joining and just waiting in line to be admitted. But anyway, I think we should start. The topic of today's webinar is well, clear. It's also in the invite and in the webinar's theme, the science of audio and video testing. I should definitely share my screen, right? So you can see the presentation that we're going to go through. Okay. Hope you can see it. All right, cool. Let's kick it off. A little bit about us, meaning the company that both of us are from. It's Tesla Lab. Some of you might have heard about it. Some of you haven't. We are a software quality assurance company. We have been in the market around 10 years, working with startups and Fortune 500 companies, helping them to evolve, enhance their services and products by providing a very wide variety of testing services, and also our internal tools and products. So yeah, if you want to know more, teslolab.com, there's a website, and I won't dig into much of that. Let's well, look at webinar agenda. 3 main sections that will span across overall time 45 minutes. First, we'll start with audio and video testing methodologies and setups. We'll talk about why do we need special testing in audio and video functionalities, what type of device setup we are using for mobile, I think it was, and what quality metrics are we analyzing and capturing. Network setup challenges and solutions. So we'll show insights of like what problems we have run into and how we solve them. Section number 2 will be the highlight of this webinar. We will show real data that we gathered over like tens of thousands of tests within different projects, and what are the most common issues that actually service providers do not know about. Well, mostly who do the testing should like earlier or later know about them. And third section is testing capabilities and competitor analysis approach. So with that, we'll conclude the kind of monologue part and go to Q&A. So motives for audio and video testing. This will hopefully answer the question, why do we need audio and video testing for? First motive, high expectations. So this is about user expectations. Features such as screen sharing, annotations, reactions, chat, video recording, etc., are definitely amongst the things that users considered default when it comes to video conferencing and streaming apps. And most in the market do have them. But importantly, we should not forget why conferencing and streaming apps are used: to deliver quality communication and content, of course. Not having able to communicate properly or deliver a message properly will overshadow all the bells and whistles that the app might have. In not so optimal user and conditions, app that will try to preserve all the features at high quality will usually end up just losing quality across the board, including the fundamental feature that we talked about of having this reliable audio communication. This particular thing is reflected in the bottom graph. Audio quality ranges from just very bad to good throughout the call. And the top graph, in contrast, does prioritization, giving the user at least good and stable audio quality. It is clear to us that prioritization of features that match user expectations have to be understood and defined. So not testing and not knowing your user experience in different real-life situations, in most cases, will just result in users switching to competitors. It's that straightforward. Second motive, based on a study, the number of European, Middle Eastern, and African organization employees working from home grew from 16 to 40%. That is 2.5 times more than before the pandemic. After that, it's expected to fall to 27%, which still is a whopping 70% more than before the pandemic. More than that, 38% of European organizations said they now encourage working from home. So yay for those who are always wanted to work from home. And they are saying they will invest in necessary IT spending to make it possible. Additionally, companies have, well, reaped the benefits of remote work in cost savings, spanning from electricity to just shifting to new offices. Well, that has incentivized them to be on this continued financial strategy also in the future. Finally, in mid and long term, shifting demographics will also leave a great impact on the work and leisure culture, bringing in the people who are just in the virtual world already more than it was before. Third motive, well, fierce competition. Logically, that if the user base grows, the market will grow as well. By all the indications, the global web conferencing market is one of the most dynamic in the entire technology world today. This is based on multiple studies and from just the numbers that we get from various sources. So in the next 5 years, market share is expected to grow at least threefold compared to 2019, meaning also more saturated market. Currently, top competitor list is around 20 plus companies already. And this is excluding the early star risers that we're seeing in the niche markets as well. And if we look at the data, in 2020 in US alone, the most used video conferencing apps were FaceTime, and then followed by Facebook, Zoom, and Facebook Messenger, Zoom, and Skype. Last, certainly not least, motive for doing the tests is the complex environment in which users can be found around the world. So those multiple factors include the one block that is like special policies on bandwidth limitations, load balancing rules, other complex mechanisms of regulating traffic, or just simply an outdated network infrastructure. That's just making the video conferencing and streaming experiences very unstable. Another big contributing factor is high network usage situations. Those are very unpredictable and can appear even on good networks. Basically, they're everywhere, and they rise from nothing. I don't know, but yeah, severely it can just lead to severe impact throughout the call or a session. And on top of all that, there are a multitude of different user and devices that can be a problem on their own, right? So combining these factors, or having a factor, individual factor on their own, can create substantial challenging situations for the audio and video transmission applications to handle. And yeah, we saw these kind of factors and issues, and we decided to do something about it. And Tesla Lab has come up with a comprehensive approach for testing video and audio solutions. Starting 2019, Tesla Lab has started to heavily invest in building dedicated video audio laboratories to simulate end user behavior in environments. Special hardware and software had been acquired to ensure all content can be captured and necessary metrics analyzed. Also, dedicated network infrastructure with isolated and highly controlled network components is built. So this is done to have a specific coverage of various test conditions and test combinations in parallel, right? So the more granular the network structure is, the more control we have over it, and we can do parallel threads in testing. Another thing which is also important that Tesla Lab did is use the existing base or fleet of more than 2,000 devices. This is to ensure the wide variability of the specific device combinations that users might have in the real world to be simulated. Also, regular quality engineers would not be suitable to do all of this niche testing. So a dedicated team of engineers is available now, and new recruits are being trained to cover any complexity of work in designated laboratories. And test accuracy and validity is the kind of cornerstone of all the results, and to have like really conclusive reports and results. And that is only achieved by following strict process and methodology, which we have developed during tens of thousands of test iterations and deep dive investigations. Now we will switch to actual device setup and quality metrics, and Nikolais will take over. Thank you.
Yeah, hi everyone again, and for those who just joined, thanks for joining, and I really hope you'll get something interesting out of it and you will get new knowledge. So I would like to introduce you to our setup for audio and video testing and to the metrics related to these types of tests. In the real world, there are a variety of device combinations used in the calls and video streaming. You can start your session with a mobile, desktop application, or you can connect to the session via web on any platform, Android, iOS, Windows, Mac. And in our labs, it's possible to conduct tests using all the different combinations of platforms. But today, I'll show you an example of our mobile setup. So basically, every setup will have three main parts. First one is sender device, where it will be the one which initiates the call and sends audio and video media to the receiver device, the one which receives this media. Second part are desktop devices, which you can see at the top. They are used to play back audio and video files and also write network traces to be analyzed later. And third one are additional equipment, such as the external monitor, which has pre-recorded video playing back in case for mobile to mobile scenario, and audio card with all the necessary cabling, routers, and web camera, which is used also to get the video latency metric. And in calls with more participants, we physically add more devices to the call, or in case there is a web version of the application available, we use our own build tool Loadero, which using Amazon Web Instances, additional participants can be generated and added to the call. So metrics. We generally divide metrics related to audio and video quality into 4 groups: audio, video, network, and performance. And all of those metrics are used to help to understand how does the application work. It also helps to unveil the problems and get to the root cause of it. And often the single metric cannot show the whole picture. You might have a good audio quality, but if other party only hears what you said after 3 seconds, do we really care about audio quality then? Maybe. It depends on product and user expectations. But as Dennis mentioned already in the beginning, expectations are quite high. And same goes with video quality. The picture may be excellent, but if you see only 1 frame per second, is that a good experience? I doubt. And then network and performance metrics can be considered as supportive. They might help a lot to get the full picture of the application and dig deeper to its behavior. And I would like you to tell a little more about video metrics we use. We use on a daily basis 2 types of algorithms: full reference and no reference. But from the start, what is video evaluation algorithm? Basically, it's just a mathematical formula that attempts to predict how we, as humans, would rate the videos. And for the full reference, the way algorithm works, it compares original image, as you can, for example, can see on the left example, and to the degraded one. And by using this way, it produces the score. What's important for full reference, images should be very well aligned. And this is possible when we can inject the media file through the virtual camera or by using hardware solutions that allow media file injection. But if we are testing, for example, a mobile platform, there is no solution for that. Or, for example, we would like to test whole chain starting from the camera itself. Then the content, it will never be fully aligned because even difference in some pixels, it will really influence the score. But then comes the second type of video algorithm, which is no reference image evaluation. And we in TestDev we use BRISC, which stands for, I will read it all, Blind Referenceless Image Spatial Quality Evaluator. Yes, it is as smart as it sounds. This algorithm uses machine learning and does not require original video to be present. The model of this algorithm can also be trained for specific video, so the accuracy of prediction will be higher. And this is the one to go when doing mobile tests. The scoring corresponds to MOS or mean opinion score of 5 being excellent and 1 being bad. And for the video quality evaluation part, not the whole area of the video is used. A certain area, also called region of interest, usually around the person in case of when this type of video content is required. Like we have right now, we have some background and we have person talking. This part around person will be cropped out first, and only this specific area will be evaluated. And for full reference, as during the video we can experience some freezes or like small dropouts, we need to generate reference video each time, so it will be fully aligned with the graded video. And to get frames per second, we can decode QR markers we use, which you can see also on the left on that screenshot, and then we get the numbers of frames per second. So also one of the most important parts of a setup in audio video testing is actually a network setup, because the degradation in the calls, they happen when we don't have, first of all, perfect network, and second of all, there are also problems with device performance. But talking again about network setup, building this network infrastructure takes effort and time, and there are some challenges that needs to be overcome. In order to have data you can trust when you start testing, and this testing is heavily dependent on network, as I mentioned, the network itself needs to be stable and act predictably. And there are some specific points I wanted to mention, which can influence instability. So first of all, internet connection for testing, it cannot be shared with anything else. If you have connection which is not dedicated, it can bring you unexpected behavior such as limited bandwidth, packet loss, or higher latencies. Second one, in big buildings with many offices, higher number of routers and access points are used, and from them interference is coming, which again can cause packet loss, increase in round trip times, resends, reorders. Also, when using many devices on the same access point, the queue will be formed and packets will start to arrive unevenly, causing us problems for the call quality. And also when large amounts of data are moved over the network, packet queues again and interruptions will be experienced. And what we have done in TestDevLab to overcome those, we have used dedicated internet connection and dedicated access points for that. We monitor our network traffic to ensure that all components in infrastructure works as intended. We also monitor radio frequencies in our offices. And for traffic limitation, we use traffic control software. And in our setup, various conditions can be emulated. We can emulate low bandwidth, packet loss, delay, packet reordering, and more, all at the same time. And this setup is also done with automation in mind. So all the tests can be automated as well. And different tests can be scheduled one after another. And I'm giving back word to Dennis.
Thank you, Nicholas. I think that was quite insightful. For the middle part and the focus of today's webinar of top 5 audio and video quality issues, we will start with a 101, so how to read graphs. This is simply just to understand the whole section that we'll be speaking about. Each graph basically will represent how a specific metric changes over a certain time period. In this particular example, we observe how frame rate fluctuates throughout a 180-second test call. There are 2 lines in this graph, each one representing an individual test. The vertical y-axis scale reflects the frames per second from 0 to 30. The horizontal x-axis shows at what point during the call we are seeing that specific FPS measurement occurring. In some graphs, we will also display network limitation changes like bandwidth or packet loss over the time of the call. So I'll specifically tell you when that will happen. So this brings us to top issue on the list. And I'd like to underline that the failure to recognize or properly handle low bandwidth situations are very common, and those occur in just slow network conditions, usually encountered when using public Wi-Fi access points like cafes, airport lounges, hotels, and elsewhere. Also, commonly low bandwidth limitations occur with a low cost data plan or after the data plan limit has been exceeded. Additionally, slow network is common across locations where either infrastructure is like underdeveloped or is just too old. Lastly, it can be just as easily due to misconfiguration or bad maintenance of local network setup. What can be done about this? Probably the worst thing that you can do is do nothing. And this is the case here. This graph represents a two-people video call on a network with limited bandwidth to 250 kilobits per second. So this is not your usual broadband bandwidth, obviously. Application is trying really hard to sustain a good quality video call, not accounting for the network conditions, which is making the video call to just continuously freeze up. And these are the spikes that you're seeing. This happens simply because network at 250 kilobits per second can't handle high quality video bitrate that produces an outgoing high traffic volume. If we would just measure the average FPS, it would be around 10 frames per second, which is fine. However, obviously, the average wouldn't represent the real feel on the user experience. Approach number two, another option, and this option includes reducing video bitrate in order to reduce outgoing network traffic. In this case, even on 100 kilobits per second bandwidth limit, as seen on the graph, the call can perform in the very acceptable region of 20 to 30 FPS, with some exceptions not dropping below 12 FPS. However, the price that we're paying for this is visible on the right. So it's low video image quality. Another approach, which is already a better approach to handle low bitrate, is creating so-called encoding ladder. This means that for each network bitrate level, the application sets a dedicated frame rate per image quality kind of ratio to try and have best experience for user. This example is clearly not ideal and can be further improved. That said, we believe that the best balance can be found by having a variable bandwidth test and adjusting the ratio based on the results. Approach number 4. So this is basically disabling video completely, and based on a fact that someone considers audio as a fundamental factor, and given that video is not benefiting the cause at all and is just not providing any added value, so it's smart to just disable the video and prioritize the audio call. This is what we saw in the motive slides as well. This brings us to top issue number 2. So first issue was about low bandwidth, handling situations, this issue is either just ignoring or not handling properly packet loss situations. And before we dig into again approaches of how we see apps dealing with this, is to say that there are two types of packet loss. One caused by signal interference connection issues, and the other, which is network congestion. So one is, the first is non-controllable, and the second is controllable. Approach A. So one of the questions that service providers have to decide is whether they want to reduce bitrate when they detect packet loss. If packet loss is caused by congestion, the reduced bitrate could help with that. However, given that packet loss is caused by some other reasons that we cannot control, bitrate reduction usually does nothing. Graph on top shows an application behavior that is detecting packet loss and starts to noticeably adjust bitrate around 8% packet loss. So if you look from the left to the right on the bottom of the x-axis, you see that it goes from 1% to 8%. So this is gradual increase in the network condition specifying the packet loss. And we can clearly see that application, when it comes to around 8%, it starts lowering and reducing the bitrate. Graph on the bottom, on contrary, shows an approach where app does nothing in terms of bitrate reduction. There is no good and bad situation here. It's just how you decide to tackle. Approach B. So instead of playing around with video bitrate or audio bitrate for sake, the other more basic approach to counter packet loss is to enable packet retransmission or even duplication, usually with small cost of delay. Here are two examples where we measure Polka audio score for service where packet retransmission is not enabled. This is on top, and where it is utilized on bottom. You can draw conclusions for yourself. So basically, we can see if the call is stable and reliable. That's definitely a much more nicer experience for the user. Issue number 3. This will conclude our issues for the network type, network related problems. And here we will talk about how apps fail to handle network bandwidth, or not maybe fail to handle, but what are different situations that we saw apps handling sudden increase or sudden availability of better network, better higher bandwidth. So there are two approaches, and everything everything in between. One is aggressive. Basically, when the bitrate is available, start to increase ASAP, and the other is the cautious approach, doing it more slowly and reducing the risks of unnecessary freezes. However, this might increase the time that user spends in a low network environment, which is, well, also not good. Specific approach A, what app is doing with this aggressive recovery approach. Let's look at the middle of the left graph, where the app recovers aggressively on applied bandwidth increase, changing bitrate quickly from 100 to 250 and a little bit slower from 250 to 500 kilobits per second. By looking at the right graph, also middle section, frame rate is fluctuating, trying to sustain some kind of fluid motion in the video when we have that 100 kilobits per second limitation. And when the network regains a better bitrate, then we also see FPS going up quite significantly and rapidly. The only downside we see to this is that each time a sudden drop or sudden rise happens, we see a freeze on the right side in the graph. A drop to the very bottom of the x-axis actually represents a video freeze or a stall. So the cautious recovery approach. In different calls, it takes around 2 minutes or more to recover back to 50 kilobits per second, as you can see on the left side of the graph. So when it drops to 100, and then we do this, we do the same with network limitations as in previous application. This application cannot go that quickly back to 250 and 500. So it gradually increases, and that in turn has an effect on frames per second metric. So the call is happening under a low FPS condition throughout the rest of the call. And yeah, just kind of recap on the previous one. I think the service provider should find some kind of middle ground, how to deal best to tackle the video freezes and use the bitrate that is actually available at that time. But yeah, top issue number 4, failure detecting dominant speaker. Feature used to prioritize the video feed of the one who is speaking, basically. If not used properly, can cause unwanted interruption in video calls. Application has to be optimized to ignore noise, short-term bursts, decide how to handle other participant audio interruptions. It's quite intricate to handle the best way possible, but still, let's look at how different approaches are being utilized in the next slide. In these graphs, orange and purple lines that we see represent 2 active speakers in one call. The black line shows the perspective of other participants in the call. Basically, if black line goes up, speaker 1 is showing on screen. If down, the speaker 2, making one or the other as dominant speaker. In the first example, which seems to be also the best, existing speaker stays dominant until he's done speaking. Only then the view switches to the other, making him the new dominant speaker. This behavior continues till end of the call. In this in this example, we can see that a fair amount of attention is distributed between both speakers and actually does not interrupt a speaker that wants to end his or her message. In the second example, just one speaker has the dominance. Notice his voice is always matched with him appearing as dominant speaker. So that, again, black line on the top. This could work in situations when someone on the call has to be prioritized, like a presenter. So it is recommended, if an app chooses this particular option or approach, that this can be a function or a setting that is triggered by the user or the host. The third example, the third graph on the bottom, looks like dominant speaker mode is being switched randomly between both speakers. It's really hard to say if this is some specific pattern behavior or just truly random to show those who are speaking and kind of give priority to one or the other. So this is very flaky. And top issue number 5, low user device performance. This this particular issue is highly linked to the vast amount of devices that users might have, right? And handling video quality issues due to low performance on end user devices can be quite challenging. Apps would need extra logic, monitoring hardware resource utilization to adjust different video quality parameters to make user experience as smooth as possible. 2 approaches that we usually see. Let's start with kind of classification tree of the devices. Basically 3 levels or 3 types: high-end, mid-level, and low-end level. High-end device is considered recent, 1 to 2 years. I think you know the devices like iPhone 11, iPhone 12, Samsung Galaxy S20, etc. Mid-level, 3 to 4 year old models. I won't necessarily go through them. And low-end, it's like 6-year-old higher spec models at that time, like Samsung S7, iPhone 6s, etc. And users are still expecting acceptable experience even on low-end device. I think like some of you for sure have friends, or you're one of those who are sticking to those really sturdy devices that just work and you don't want to switch, right? And you are one of those who expect the quality still be intact when you have a call or join kind of a streaming session or anything like that. And so when we look at the example A, or example to the left, where Samsung A10, a low-end device, is being used, it provides really good user experience by limiting the frames per second. It's not the only metric that can be limited, but one of the most resource heavy, let's say. And on the right side, same device is being used, but app is just trying to maintain a high frame per second call, and that just screws up the experience for the user. So yeah, it has to be balanced for different types of devices. I think just knowing the user base and what types of devices are being used is truly essential. So yeah, third section, let's talk about testing capabilities and competitor analysis approach. This will be kind of wind down and hopefully lead to a Q&A session. So for every application, it can have different features and flows. Within same functionality, there can be also many different use cases. For audio and video call, we might want to test scenarios such as webinar with hundreds of participants like we are in now. Peer-to-peer calls like 2 people video chat, working group meetings, 5 to 20 whatever participants, team events with as many participants or more. It can be also an audio only call. So all of cores can be subjected to various changes in network conditions and using different combinations of devices that we already went through in real data examples and those issues that we discussed. In the video streaming products, there might be a number of latency settings like ultra low, low, and normal. Application behavior will depend on these different scenarios and settings. And then to top all of that, it is important to know how the applications compare to the competitors in order to see where are you in the market, and how well are you doing against them? Competition analysis approach. As mentioned in the beginning, competition is quite dense between the audio and video communication streaming products. In order to understand how your application sits in the market, what are the strengths and weaknesses of it, the good way is to conduct simple competitor analysis. With an existing testing approach, it is possible to produce same tests on a wide range of different products. So consistency and repeatability is key. Making sure that the setup that you're using or you're using someone else to produce a specific setup, it has to be a stable and very in a very controlled environment, right? If we look at how to kind of compare the data, or the ways to look at the data, here are some examples of how it can be achieved. So on the left, it is classified by different network conditions. And it would be really interesting to see, like, if all conditions compared to competitors, compared to market leader, are the same. So in this example, we see 500 kilobits is definitely something that needs to be looked at. In the middle graph, it can be grouped by platforms, and on the right, it can be grouped by scenarios. That's simple. In order to get the whole picture of the audio and video product performance and user experience, many different metrics should be combined, linked together, and analyzed. This way, we can understand where do the bottlenecks lie and what could be the cause of those. It can be a single metric, individual metric, or it can be a combination of something. So it's like a mix and match and trial and error, depending on specific goal that you want to achieve. And yeah, I think generally we can divide all reporting in technical and non-technical. That's what we usually do, and the report should be clear for both of technical and non-technical user groups. And of course, we're making sure that test analysis cover both high-level and low-level results. Let's have a quick recap. What was kind of the main points of the discussion. So for the top issues and best practices, ignoring or not properly handling low bandwidth. So best approach would be variable bandwidth tests. Make sure that increase bandwidth from low to high and back down to get that, to get those particular properties and parameters out for the encoding ladder buildup. The same or very similar would be for the packet loss. Again, just the variable packet loss settings. And that could help you build retransmission and duplication. The third issue group was failure, recognizing or handling bitrate recovery. Again, very similar to variable bandwidth tests. This time it's just increasing bandwidth tests. That could help build balanced recovery policy. Fourth is failure, detecting or handling dominant speaker. Again, best approach, we think in our mind, is kind of just doing the dominant speaker test and look at what works best in your particular situation or service provider's particular situation. And the first thing that we talked in the issues section was failure to acknowledge mid, low end users and, well, their devices. So our recommendation would be wide device range tests, knowing your user base, what devices they're using, monitor device health when doing the test, and adjust accordingly. And the recap of why and how to test. Again, I think basic and the most important point here is understand the user experience. To do that, you just need to have a proper suite of non-functional testing for audio and video. So we also noted down the kind of main motives, like working from home has become the new norm. Booming market equals lots of competitors. I think it's just quite obvious. Bad user experience. Now users are just very picky, and they will, with high expectations, they will switch to competitors. There are options. Don't forget that. Comparison to competitors. This is how you grow, how a service provider would grow and improve further. And preconditions of successful video and audio testing, just stable, highly configurable network infra, right user device and capture device setup, strict methodology process, and right tools, and have trained people who understand the metrics, understand the setup, understand the network configurations, and yeah, things around that. Yeah, that concludes our monologues. So hopefully, guys, you have prepared some questions. We will now answer those. I'll mute myself so Nikolais can read them out.
Yeah, thanks, Dennis, for this good speech. So we have one question from Swapan about tools used for automation to conduct network condition tests, and particular in bandwidth setting in particular. And as I mentioned earlier, yeah, we use traffic control software, and you can just Google it, and it's open source, and documentation is very well written, and you can control both outgoing and incoming traffic with it. And yeah, we use a Linux machine and TC set, which is a wrapper for traffic control. It acts as a router, and this way we can control the traffic. So yeah, using Linux machine, traffic control software. Right now, I don't really see any more questions. I know today at some point we will give opportunity for
Nikolais, may I interrupt you?
Yeah.
I think we can allow now to have an open discussion. I'll allow you guys who are still on the call to unmute yourselves. Just give me 1 second. Yeah, here. So now you're free to speak. Please don't swear around or use any rude words. Yeah, and if you have any questions, please, you can ask them now. We'll try to address them.
Hey guys, thank you very much for the very informative presentation. I really liked it. So my question is, what is the right approach to test this low bandwidth test? So like, do you guys automate on the app level, like simulating the video call and monitor bitrate or frame drops? Or is there any other better approach for testing these matrices?
Yeah, so for those metrics, we use it on application, as you mentioned, for desktop to desktop platforms. Yeah, we can film content with camera, we can inject the video, and on mobile, yeah, we can only film the screen, as we have shown in example. But yeah, also using physical devices and having the actual call, like the user experience, is what we think is the best sort of testing approach for that.
Yeah, and I'll add to what Nicholas has said. Basically, any tools that you could use for automating the UI on both web or mobile or desktop could be used to simulate the users actually making the call, setting up some kind of meeting room, a session, others joining in. And what's important then there is actually how the captures are going on, right? How well it's all parts are important. I think before the call itself, you have to set up a specific network condition, and Nikolai's already answered that question. You look into those open source tools, and that is just a combination of different scripts and tools chained together, linked together to just build one specific suite of video and audio test for a specific condition, for a specific scenario. It's just really hard to answer specifically, right? It's just like we're trying to answer in general. But yeah, it's just combining various techniques of test automation that you should be using regularly, with some additional things, just scripting and adding all together.
And second part of the question is, how do you monitor those bitrate or frame drops? So do you have a separate external service where you check those matrices while the test is going on? I'm talking in terms of automating those test cases.
Yeah, I can probably answer to that. So we don't actually do that in real time. We record the incoming video, and we have our pre-recorded material, which has QR markers on top of it, which are changing. Like if we are testing a video with 30 frames per second, so the markers will change 30 times a second. And we also get in the network traces, and we make analysis after the test. So we record the files, we save them, and then the processing part comes in. We do it this way.
So execution and verification take place in separate things.
Yeah, at later stage after the test.
Okay,
And
thanks.
just to mention, it can it still can be automated. It just takes a part in in 2 stages.
Yeah, this is in our engineer Richard, yeah, in the call. Hey, Richard.
Hello.
So yeah.
Hello, good evening.
I'll quickly comment as well here. So on the FPS, I think we, like Nikolai's answered, it's a special technique that is developed, well, let's say in-house, but it's also an open source kind of algorithm. It's just we have leveraged that to this particular use case, and it's a script that again can be linked with an output that's coming from the actual capture. We feed it and we get some kind of output, and then we assert it. So that's just again making sure that the link of inputs and outputs is done correctly to get the necessary result. And on the bitrate, was the question specific to video bitrate or network bitrate?
Video bitrate.
Yeah. For that, Richard, correct me if I'm wrong, but we're using Wireshark mostly. Or
Was it video or network?
Video.
I mean, for video bitrate, which is like how much encoding is done, it's more about utilizing the full reference or non-reference algorithms to just get the quality of the video. I like the actual bit, like we can check the video bitrate, like the actual, like how much data we are sending through the traces, through the network traces, but obviously the quality at which like the video is encoded, since sometimes like the not full bitrate, the full video like bitrate is used in the actual video. For that we need to use like the reference full like video algorithms, quality algorithms that you use. Yeah.
Yeah, I can also add to that because the way we record our videos, the bitrate, it will be actually the screen recording bitrate, because we do the screen recording if it's a desktop with FF MPG, or if it's Android, we do it with ADB, and you can actually specify where the bitrate of recording. So, but yeah, as already Dennis and Richard mentioned, we can analyze traces, and we can remove UDP headers if traffic goes through UDP or TCP headers, and also if in packet there are TZSP headers, we also remove that just to keep the UDP data without headers. Yeah.
Thanks. That answered my question.
Okay, cool. Thank you for your question. Anyone else wanting to join the conversation? I think we're getting warmed up.
Hello, good evening. Can you hear me?
Yeah, we can hear you. Good evening.
I'm sorry I joined late, and I would like to ask if, because I figured out this meeting is being recorded, if after the meeting we can get the link to this recorded tape.
Yeah, of course. Yeah, we'll send it out with the presentation itself.
Thank you. Secondly, I would like to know if I know this is out of context, but I would love to ask regardless that is there a way we can create a group where we can all learn from one another regarding quality assurance in general, and then perhaps share job opportunities with one another in future?
Did I understand correctly that you're looking for future partnership?
Yeah, something like that.
Okay. If you see the slide on screen, you can reach out on LinkedIn to me or Nikolais, or write an email on info@teslab.com, and we'll make sure that we can set up some kind of call between us and talk about the details. What are you looking into specifically?
Okay, I appreciate that.
Yeah,
okay.
Cool. Thanks.
Thank you.
Hi guys. First of all, great presentation, really useful. I have a little different question. It's about applications, music applications, but for singing, for recording, let's say, and not a streaming service. And my question is about automation. Is there a way or a tool, for example, to help with checking the audio/video quality of a recording, pre-render and post-render?
Yeah, there is definitely a way, because especially for video quality, if we talk, so pre-render and post-render, we can conduct full reference and also no reference evaluation. And for audio, same. It's just we won't use the random content, but we will use our pre-recorded whether music or voice content, and then we will compare it with encoding, with what we have as a degraded file after all the processing. And on audio side, this can be done with Polka or Viscol, and they both have also wideband modes, which measures up to 16 kilohertz in frequency. And yeah, and so you can compare how it looks like with different resolutions and different codecs and etc. and with competition. Yeah.
Nice. Thank you very much.
Thank you, Lubomir, for your question. Do we have any more coming in, or we can talk about weather? No, just kidding. Yeah, quite warm evening actually, or quite warm evenings are happening. Oh, I'm hearing some echo. Someone's trying to have a question.
Is it possible to do tests with broadband cellular network, for example, 4G, and see how much data was used to do the testing?
Yes, for 4G, for 3G, for 2G, there are certain profiles, and we can do the same as we discussed for automation using traffic control. We like both 2G and 3G and 4G, like it can be different. Like 3G good connection can be considered like 1-2 megabits, and like 3G poor connection can be like 500-200K. So first of all, we need to decide on that, and yes, so we apply that condition and then record the traffic from a device and analyze it.
If my add, we can also obviously run tests in like or like native on like native 2G, 3G, 4G network, but there we can only like if we are like using Wi-Fi, we are only then able to capture the traffic. So from 4G to Wi-Fi, and then we capture traffic on receiver side. And there is a node that like the problem there is that actually between countries, like this infrastructure might be different when it comes to like these 3G, like any network technologies. So that's why we like usually what Nicholas said, advise to use the traffic control to imitate the network that is needed.
Actually, there are some new equipment. MikroTik routers offer packet sniffing using 4G and 3G network. So actually, it's also possible to use real devices with 3G and 4G connection and get the traffic. So yeah, we have this opportunity.
Okay, thanks for your answer.
Just to add here, we can also use tools like Charles Proxy. I mean, I'm using it as a command line tool in my automation scripts, where I'm controlling the network in all my native and the web devices.
Yeah, valid point.
Yeah, thanks for insight. Yeah.
The proxy question: is it possible, for example, to simulate a device inside America or Netherlands or any other country in the world?
So, Adrian, was it a question for a child's proxy software?
No, it's more related question to like testing. Can you test like if device is located in the USA? Can you do a test like that?
Yeah, like there are several options for that, and one of the options is VPN, but we do not suggest going with these options because the results are highly dependent on how heavy VPN is used, and you cannot really guarantee the like same as we can set up the network infrastructure here and guarantee that it's a dedicated connection and environment is stable, but with using VPN, we can't really guarantee that. And in our experience, the best way is to understand what is different in that country, like what are the network conditions in that country, what are the popular devices used by those users, and so use those devices and simulate network conditions in this country. But there are also we have partnership with a company which also gives access to the physical devices set up in specific countries. I think it's like something like 50 countries around the world, but it comes with a quite high price. So yeah, which is not suitable for everyone, but there are solutions for that.
Okay, thank you for the answer.
Yeah, I don't know about you, Dennis. I think it was quite active. Yeah, I didn't expect anyone to really ask questions. Yeah, so yeah, it's nice. Anyone else maybe? Anyone can also share some experiences. Like we had a participant talking about Charles Proxy. Sorry, I didn't catch your name. Yeah.
Can you hear me?
Yeah.
Yes.
Hi. Okay. I have a question. Are you considering the jitter in the test? How you can handle that kind of situation when the packets are in different orders when they arrive to the endpoint?
Can you, Oscar, repeat the first part? Jitter, you said, yeah?
The jitter. Are you considering the jitter in the testing? I know you mentioned the packet loss, the delays. Yeah, I want to know how you test the jitter in the lab that you build.
Mm-hmm. Yeah, by using the same software, traffic control, and it has also option for jitter. So the condition can include both jitter and packet loss and bandwidth. So yeah, this is all possible and done.
Okay, and I read that you handle, for example, with the packet loss, you try to retransmit the packets, yeah, in order to deal with the packet loss, yeah.
Actually, maybe you misunderstood a little, but actually we have been discussing on what actually could be done on application side, on the code itself, on development.
Okay.
Yeah.
Okay, thanks. And yeah, and then the question will be how we can deal with the jitter in that case when the packets arrive in different orders. Retransmission could be a good approach, or
We've seen, yeah, Richard, go.
Yeah, I mean, it's handled usually on application side. So if the traffic is usually like for communication applications, it is RTP traffic. So which means that like the packets themselves are numbered, and if they arrive in wrong orders, then application should like be able to just reorder them as they are needed. As like RTP again, like it should be handled on like application side by just reordering them as is needed.
I also can join in here and tell that one of the options also is to when application understand that there is a jitter happening, then delay also can be increased. So there is more time to do the things what Richard mentioned.
Yes, so-called jitter buffer, basically.
JB.
Does that answer your question in any way?
Oscar has already run to the developers and saying, guys, this is the way how you should deal.
UDP is not the way, RTP is the way.
Oscar, are you still here with us?
Yeah. He answered the question.
Okay, cool. Appreciate the question.
Thanks.
Yeah, I want to share my experience. In my case, like I'm working in a video streaming company. So my responsibility is also to test those everything which is related to the video player. And in the native applications, what I used is with the help of the developers, they provided me the matrices, or you can say the real-time data within the application on the UI itself. So while testing or while simulating the videos, I just test those numbers within the UI itself. So I don't need to go anywhere in the logs or anywhere in the other matrices services.
So do I understand correctly? You mean the question is of?
It's not question. It's just
it's not
sharing
really
the
a question.
experience.
Correct. Yeah, but if you would like to test the competition, then there won't be such debug UI. Although, like some, like YouTube offers, yeah, like they call it stats for nerds, and you can check like codec information and network bitrate and latency, but not so many products offer that information. Also Zoom, I know also in Zoom you can check, and in this Discord you can check also some stats, but yeah.
No, it's not in the production build. It's only in the debug build that they provide me those stats.
Yeah, obviously. One thing also we have to be like to warn you. Some things like, for example, frame rate. Like even in the stats, when the frame rate is reported, it's often very like kind of necessary to try to check the stat quality from outside standpoint, because like sometimes like what is reported in stats as rendered frame rate does not match what is actually seen on the screen because of some performance issues or something like that. So that's just something to like to take in mind, that those stats sometimes can like lie and have to be checked also if possible from like end-to-end perspective.
Yeah, thanks. So I need to see how reliable this approach is. This is also new for me. Yeah, that is why I was looking for some other approach.
Good. Yeah. Thank you, Richard.
And also, yeah, we can probably add for someone who is interested to know more about our solutions. We usually offer like small insight and conduct just like limited amount of tests on the application, just so you get a feeling of how the process is done and what metrics you get and so on. So you can have a peak already without putting a lot of resources and finances. Yeah.
So Nicholas, what's happening? Anyone waiting for you back at home?
Anyone waiting? Yeah.
Cool.
Probably the same for you. Yeah.
Also anyone. We might have the same person waiting for us. Is that anyone? No.
Maybe if only you talk about like Netflix TV show or something like that, when the same person, like the actor.
Yeah, probably. All right, guys. I'm feeling that we're again like winding down. I'd like to say hi to Shagufta. I saw her on the call. I know she's just being shy. And not sure if she's still on the call. And yeah, thank you all for. Sorry.
She's
Okay, cool. So hi. But yeah, thank you all for joining and being with us throughout the full presentation, or even joining at in the middle, or at some point. So thanks for joining us. Thank you those who have asked questions and participated in the discussion. So yeah, I think it was quite productive, and I'll give also word to Nikolai.
Yeah, thanks for questions. I think it was really good to hear some other perspective how things are done in other places. Yeah, and yeah, if you have any questions, just do not hesitate. If you have any more ideas you wanted to discuss with someone, or understand how to make the application work better, or how to troubleshoot some issues, just drop us a message. Yeah, we'll try to help.
Yeah, don't try to write down the addresses or anything like that. We'll send you the presentation. We'll send you the recording, and yeah, make sure to ping us, and let's see if we can help each other out. And again, thank you for joining. Have a nice rest of the evening, day, morning. So yeah, thank you. Goodbye.
Bye-bye.
Bye, guys. Thank you.
Bye, guys. Thanks for the presentation.